A plant that grows on roadsides across temperate climates contains roots composed of 40 to 60% inulin by dry weight, a prebiotic fiber that feeds beneficial gut bacteria and is now extracted industrially and added to protein bars, fiber supplements, and low-sugar processed foods consumed by millions who have never seen the plant. The same root, when roasted, has been used for centuries as a coffee substitute, consumed daily across Europe during the Napoleonic Wars, the American Civil War, and both World Wars. The plant's taproot descends 1 to 2 meters into the soil, breaking compacted layers and pulling minerals upward, improving fertility for crops that follow. It was cultivated deliberately by ancient Egyptians and Romans. Today, it is classified as a roadside weed. There is a plant whose roots are 40 to 60% fiber, not the insoluble fiber of bran or cellulose, which passes through the digestive system largely unchanged. This is a different kind, a carbohydrate polymer called inulin, built from chains of fructose molecules that the human digestive system cannot break down. Inulin is not digested in the stomach or small intestine. It travels intact to the colon, where it serves as food for bacteria, not harmful bacteria. The beneficial strains, bifidobacteria, lactobacilli, that support digestion, synthesize vitamins, and regulate immune function. This is what nutritionists and food scientists call a prebiotic, a substance that feeds the microbiome, and this plant produces it in concentrations unmatched by almost any other food. When the roots are dried and analyzed, the inulin content ranges between 40 and 60% by weight. For comparison, most vegetables contain inulin in trace amounts, 1 or 2% at most. A few, like Jerusalem artichokes and garlic, reach 10 to 20%. This plant doubles that. And it does so while growing in places no crop would tolerate, along roadsides, in abandoned fields, in the gravel shoulders of highways where salt accumulates and soil compacts under the weight of passing trucks. It thrives in ground that has been degraded, stripped, or poisoned by neglect. The roots descend deep, 1 meter, sometimes 2, straight down through layers of clay and hardpan that stop most plants at the surface. As the root grows, it creates channels. When it dies and decomposes, those channels remain, allowing water and air to penetrate deeper. Other plants follow, their roots using the paths this plant has made. And as the root reaches into the subsoil, it pulls minerals upward, calcium, potassium, magnesium, and deposits them in the leaves. When the leaves die back, those minerals return to the surface, enriching the topsoil. This is a plant that improves the ground it grows in. It asks little from the soil and gives back more than it takes. From an agricultural perspective, this is the opposite of extraction. This is restoration. But the roots were not valued for what they did to the soil. They were valued for what they became when harvested, dried, and roasted. They became coffee, not coffee in the botanical sense, but coffee in function, a dark, bitter beverage, brewed hot, consumed in the morning or after meals, used to stimulate digestion and provide a ritual of warmth in cold climates. The roasted root has no caffeine. It produces no stimulant effect. But it tastes similar enough to coffee that for centuries, across Europe and beyond, it was used as a substitute when real coffee was unavailable or unaffordable. And for much of history, coffee was both. The historical record reaches back to the ancient world. The Egyptians cultivated this plant. It appears in records from the New Kingdom, described as a green eaten fresh and a root used in preparations whose purposes are not always clear. The Romans knew it as well. Pliny the Elder mentioned it in his encyclopedic writings on natural history, noting its cultivation in gardens and its use as a cooked vegetable. But it was in medieval and early modern Europe that the plant's role expanded. The leaves were eaten as a bitter green, often blanched to reduce their astringency. In Italy, in France, in the Low Countries, the plant was grown in kitchen gardens alongside cabbages and onions. The greens were understood as digestive, something that stimulated appetite and aided the breakdown of heavy, fatty foods. The roots, too, were eaten. Boiled, roasted, or baked, they appeared in peasant diets as a winter vegetable, stored in cellars alongside turnips and carrots. But the transformation of the root into a coffee substitute came later, driven by economics and war. coffee, introduced to Europe in the 17th century, became wildly popular. But it was expensive. The beans were grown in distant colonies, Java, the Caribbean, Brazil, and shipped across oceans. Taxes and tariffs raised prices further. For much of the population, coffee was a luxury. The roasted root of this plant offered an alternative. It was grown locally. It required no importation. It could be cultivated in home gardens or harvested from wild populations along roads and field edges. When dried and roasted, the root developed a dark color and a flavor that, while not identical to coffee, was close enough to satisfy. By the late 18th century, roasted root was being sold in markets across Europe, often blended with real coffee to stretch supplies and reduce cost. Manuals on household economy recommended it. Agricultural guides described how to cultivate, harvest, and process the roots. And then came the wars. When Napoleon imposed the continental system in 1806, blocking British trade with Europe, coffee supplies collapsed. The price of beans, already high, became prohibitive. Across France, Germany, and the Netherlands, people turned to substitutes. Roasted grains, barley, rye, were tried. But the roasted root of this plant became the most widely used replacement. It was not a famine food in the sense of something eaten only in desperation. It was a practical adaptation. Families who had been drinking coffee simply switched to the roasted root, and many continued to use it even after the blockade ended, because it was cheaper and locally available. The same pattern repeated in the American Civil War. In the South, Union naval blockades cut off imports, including coffee. Confederate soldiers and civilians roasted whatever they could find: acorns, sweet potatoes, peanuts. But the root of this plant, which grew wild across the region, became one of the primary substitutes. In New Orleans, where French settlers had brought both the plant and the tradition of roasting its root, the practice became so entrenched that even after the war, coffee blended with roasted root remained the local preference. It still is. During the First and Second World Wars, the pattern repeated across Europe. Coffee was rationed or unavailable. Roasted root reappeared. In Germany, in France, in Britain, people who remembered how to prepare it, or who learned from older generations, roasted the roots and brewed them as they had done a century before. And when the wars ended and coffee returned, the practice faded again. But the plant did not. The plant did not fail. But as global trade stabilized in the mid-20th century and coffee became cheap and abundant, the need for substitutes disappeared. Industrial agriculture in Brazil, in Colombia, in East Africa, produced coffee at scales that drove prices down. Instant coffee, introduced in the early 20th century, made preparation faster. Coffee became not a luxury, but a commodity, purchased in supermarkets, consumed daily by populations that a century earlier could not have afforded it. The roasted root, which had been economically competitive when coffee was scarce, could not compete when coffee was abundant. Harvesting the roots required labor: digging, washing, drying, roasting. There was no machinery to do this at scale. There was no infrastructure, and there was no market demanding it. The leaves, too, fell out of favor. They were bitter, intensely so, unless blanched or harvested very young. Modern palates, shaped by decades of access to sweet and mild foods, rejected bitterness. The fact that bitterness had been understood as medicinal, as something that aided digestion, no longer mattered. Bitterness was unpleasant, and unpleasant foods were not purchased. Agriculture, increasingly mechanized, had no use for a plant that grew wherever it wanted, that reseeded itself aggressively, that appeared in fields without being planted. The plant was reclassified, not as a vegetable, not as a crop, as a weed. And like other weeds, it was removed. Herbicides killed it. Mowing cut it down before it could flower. The plant persisted. Its deep taproot made it nearly impossible to eradicate. But it no longer fed anyone. The knowledge of how to prepare it, how to reduce the bitterness, how to roast the roots, how to blend them with coffee or brew them on their own, that knowledge stopped being transmitted. Cookbooks stopped including it. Seed catalogs stopped selling cultivated varieties. By the 1970s, in most of Europe and North America, the plant had been forgotten as food. It grew everywhere, along roadsides, in vacant lots, on the edges of agricultural fields. Its blue flowers appeared in summer, ignored by everyone except bees. It simply fed no one. In the late 20th century, food scientists began studying inulin. They were not looking for this plant specifically. They were investigating dietary fiber, trying to understand how different types affected digestion, gut bacteria, and metabolic health. Inulin emerged as particularly interesting. Unlike cellulose or other insoluble fibers, inulin is soluble. It dissolves in water and forms a gel in the digestive tract. It is not digested by human enzymes, so it provides no calories. But it is digested by bacteria in the colon, which ferment it and produce short-chain fatty acids that have been linked to various beneficial effects. This made inulin valuable, not as food in the traditional sense, but as a functional ingredient, something that could be added to processed foods to increase fiber content without adding calories or affecting texture. And when researchers looked for sources of inulin that could be extracted at scale, this plant was the answer. The roots, which had once been roasted for coffee, were now harvested, dried, and processed to extract the inulin. The extraction process involved hot water, filtration, and concentration, producing a powder that was nearly pure inulin. This powder is now added to protein bars, fiber supplements, yogurt, bread, and dozens of other processed foods. It is listed on ingredient labels as inulin, chicory root fiber, or sometimes just fiber. Most people who consume it have no idea what it is or where it comes from. The plant that was forgotten as food is now consumed by millions, invisibly, in products designed to replace the fiber that modern diets have removed. From a nutritional perspective, the leaves are also significant. They contain high levels of vitamin K, essential for blood clotting and bone health. They contain vitamin A, in the form of beta-carotene, in concentrations comparable to other leafy greens. They provide calcium, potassium, and magnesium. The bitterness, which made them unpalatable to modern tastes, comes from compounds called sesquiterpene lactones, lactucin, and lactocopacrine, which have been studied for their effects on digestion and bile production. Traditional use of the leaves to stimulate digestion is not folklore detached from chemistry. It is observation that aligns with the presence of these bitter compounds, which do in fact increase bile secretion and gastric motility. From an agricultural perspective, the plant represents resilience. It is perennial. Once established, it returns year after year without replanting. It tolerates drought better than most crops, its deep taproot accessing water that shallow-rooted plants cannot reach. It grows in poor soil, in compacted soil, in soil too degraded for conventional agriculture. And as it grows, it improves that soil. The taproot breaks through compacted layers, creating pathways for water infiltration. The root channels, once the plant dies, remain, allowing subsequent plants to root more deeply. The minerals pulled from the subsoil and deposited in the leaves return to the surface, building fertility over time. The flowers bloom from midsummer into autumn, providing nectar and pollen when many other plants have finished flowering. For bees and other pollinators, this late-season food source is critical, helping colonies build reserves before winter. The plant asks almost nothing. It needs no fertilizer. It needs no irrigation once established. It needs no pest control. It has few natural enemies. It simply grows, wherever conditions allow. And yet, it remains outside the systems that define what counts as food. The plant is called chicory. The name is old, derived through French and Latin from the Greek, though the exact etymology is uncertain. In different languages, it has different names: Cicorium in Latin, chicorée in French, zicory in German, cicoria in Italian. The names differ. The plant does not. It grows today across every temperate region. In Europe, in North America, in Australia, in parts of Asia and South America, anywhere the climate supports cool season growth, chicory establishes readily. It is found along roadsides, in pastures, on the edges of agricultural fields, in vacant lots and waste ground. The plant is perennial, forming a low rosette of leaves in its first year. The leaves are dandelion-like, long, lobed, often deeply toothed. In the second year, a tall flowering stalk emerges, sometimes reaching a meter or more in height. The flowers are distinctive, bright blue, occasionally white or pink, opening in the morning and closing by afternoon. The root is thick, pale, and fleshy, resembling a small parsnip. It is this root that contains the inulin that was roasted for coffee, that is now harvested industrially for fiber extraction. Harvest is straightforward, but labor-intensive. The roots are dug in autumn, after the plant has stored energy for winter. They are washed, sliced, and dried. For roasting, the dried slices are heated until they darken and develop a toasted aroma. The roasted pieces can be ground and brewed like coffee, or blended with real coffee to stretch supplies and add body. The leaves are harvested young before the flowering stalk emerges, when they are most tender. Blanching reduces bitterness, either by placing a pot over the growing rosette to exclude light, or by boiling the leaves briefly before sautéing. The flavor is assertive, better suited to pairing with rich foods than eating alone. Cultivated varieties exist. Some have been bred for larger roots, grown commercially for inulin extraction. Others, like radicchio and Belgian endive, are forms of chicory that have been selected for the leaves rather than the roots. These are sold in supermarkets, eaten in salads, and recognized as food, though few consumers realize they are the same species as the blue-flowered plant growing by the roadside. For foragers, wild chicory is easy to identify and safe to eat. The blue flowers are distinctive. The rosette of leaves, the tall flowering stalk, the milky sap. These features taken together are unmistakable. It grows in accessible places. It does not require hiking into wilderness or navigating private property. It appears in public spaces, along roads, in parks. It is, in most regions, one of the most common plants, and it is still here. Still growing on roadsides, still sending roots deep into compacted soil, still pulling minerals upward and leaving the ground better than it found it. Still blooming in summer, feeding bees when few other flowers remain. Still producing roots that are 40 to 60% fiber, used now not for coffee but for processed foods, consumed by millions who will never see the plant. Still ignored by those who pass it every day. The knowledge was always here. It was written in Roman texts, in medieval herbals, in wartime manuals on household economy. It was practiced by soldiers who brewed the roasted root in trenches, by New Orleans families who blended it with coffee, by grandmothers who blanched the leaves and served them with vinegar and oil. We just stopped bending down to dig.